We're going to work through example 2 and 3 for lesson 3.3 in the additional examples packet in this video. Now, before we start on example 2, something to keep in mind. We have a list of all these theorems now that we know for our special angle pairs. And so we've got our corresponding angles theorem, our alternate interior angles theorem, and so on. All the ones at the top, the ones that are now highlighted in green, we use these theorems when we already know the lines are parallel and we're trying to prove something about the angles, maybe to prove that they're congruent or supplementary. Now, the new terms that we learned today, these that are bolded in red, these are the converse statements of the theorems above. Now, we use these in our proofs when we're trying to use angles in order to prove that lines are parallel. So when we're trying to prove that lines are parallel, we're using the converse statements. So we're going to try to keep that straight as we do our proofs together. So we're going to start with example 2. We need to prove that if two lines are cut by a transversal, that the alternate interior angles are congruent. We're trying to prove that if two lines are cut by a transversal so that the alternate interior angles are congruent, we're trying to prove the lines are then parallel. So we can see that we are given in the picture that angle 4 is congruent to angle 5. We're given that here. Okay. So if we're proving this, and here's our 2-column proof, that first statement is given. Notice at the end, our goal is to prove that line G is parallel to line H. We don't know that yet. We're going to try to prove that. So this kind of tells me right here that one of my converse theorems is going to need to be in this final box. Remember, because we use those to prove that lines are parallel. So let's go ahead and look at angles 1 and 4. And we want to ask ourselves, okay, we know angle 1 is congruent to angle 4, but why? How do we know that these two angles are congruent? Do they form a special angle pair? And we can see in the picture that angle 1 and angle 4 are vertical angles. So we know that vertical angles are always congruent. So my reason for knowing that angle 1 is congruent to angle 4 is the vertical angles theorem, or the VA theorem. So now, after concluding that angle 1 is congruent to angle 4, we're able to say now that angle 1 must be congruent to angle 5. We can see that in the picture. They both have one arc on their angles. And so we have to think about what property are we using to be able to take these two statements here and conclude this third one. Notice how angle 4 is congruent to both 1 and 5, which must mean, therefore, that angle 1 is congruent to angle 5. That's the transitive property. Or you could think of that as the substitution property, substituting angle 5 in for angle 4. Either would be fine. And so now, looking at angle 1 and angle 5, we know they are congruent now. So we're asking ourselves, do these form a special angle pair? And angle 1 and angle 5, they are corresponding angles. They're in matching spots. And we know that if corresponding angles are congruent, then line G and line H must be parallel to each other. So to prove that line G is parallel to line H, we are using the corresponding angles converse. We knew that the angles were congruent, therefore the lines are parallel. The last one we're going to do is example 3. Here's another proof. This one is one where we're going to have to fill out more of the statements instead of the reasons. Okay, so we have this picture here. It says in the diagram, line R is parallel to line S. That's why they have these little arrows here. They also tell us angle 1 is congruent to angle 3. I'm going to go ahead, put that in my picture with arcs, and now I need to put that in my proof, and that's given to me. Angle 1 is congruent to angle 3. Our goal is to prove that line P and Q are parallel. So I know this, it will be my final statement. I'm trying to prove that those lines are parallel. So let's go ahead and go back up to this statement. Angle 1 is congruent to angle 3. That might be helpful later on, okay? Next, we have to figure out what other two angles do we know have to be congruent, right? Because we know that R and S are parallel, so that might help us find some more congruent angles. And they give us the hint that, hey, you're using corresponding angles. So I need to look at my two parallel lines. Right? Here are my two lines I know are parallel. And I'm asking myself, do I see any corresponding angles that are formed by these two parallel yellow lines? And if I look, I notice that this transversal that cuts through line Q makes 2 and 1 corresponding angles. And we know that if the lines are parallel, that corresponding angles must be congruent. And so we are able to use the corresponding angles theorem to say that angle 1 must also be congruent to angle 2. So now remember, our goal is to prove that P and Q are parallel. So our goal is to try to prove something about angle 2 and angle 3, okay? We're interested in, are these guys congruent? And so let's see if we can figure out if 3 is congruent to 2 using our statements up above. Well, angle 1 is congruent to both angle 3 and angle 2. So that would mean angle 2 and 3 also have to be congruent. And from using these two statements up above, we're using the transitive property to say that angle 2 is congruent to angle 3. Now this is already filled in, but let's just make sure this makes sense. If angle 2 and 3 are congruent, that would make these alternate interior angles. And we know that if alternate interior angles are congruent, then line P must be parallel to line Q. And so that works.